Hi everyone, this is a video explanation for question number 4. Question number 4 reads, the mining cart is being pulled. One person pulls the cart to the left, while another person pulls the cart to the right. They pull with different forces. Okay, so we go to our simulation. One person pulls to the left, one to the right with different forces. So I'm going to pick a small dude for the left and a big dude for the right because they're different forces, so we pick different sized people. Okay, and if we run the simulation, I'm going to click the speed on so that I can see it. If we run the simulation, what happens? They're pulling, the speed is increasing. Okay, woohoo, red wins. Now, so that's our scenario. And the first step is to draw the schema. So what is involved in this simulation? Well, lots of stuff. Here we have a schema of the cart and all kinds of stuff around it. So it's a bit complicated right now. We will simplify this. So we have the cart, the ground with a normal force, the cart and the left rope with a tension, the left rope and the blue person with applied force, the cart with the right rope, also tension, the right rope with the red person, which is applied force, the cart with Earth's gravitational field with the red person, the blue person, the cart, and the ground. And then, of course, we have the people and the ground with normal force. So really, we want to focus on the forces that are acting on the cart. So we are going to focus in on the tension, the normal force between the cart and the ground, force of tension between the cart and the right rope, and the gravitational force between the cart and Earth's gravitational field. So we are going to simplify that and clear up some of those extra things. So this is our schema. Now our task is to draw a force diagram for the cart. So we're going to represent the cart with a dot in the middle. And we have the Earth's gravitational field pulling the cart down. And we're going to notate that by the force of gravity. And the agent is Earth's gravitational field on cart. The cart is the victim. It is feeling that force. In the opposite direction, we have the ground on the cart. That is the normal force of the ground on cart. Okay, notice that the cart is not moving into the air, nor is it sinking into the ground. That is because these are opposite forces and they have equal magnitude. We are indicating that with congruency marks. So we have the ground and Earth's gravitational field accounted for, and we have the cart, the force of tension for the right rope and the force of tension for the left rope. If we look, we know that the right rope is going to have a greater force since I put the bigger person on the right. You could have put the bigger person on the left, in which case your left rope would have the larger force. Since the right rope has a larger force, I'm going to draw an arrow going in the right direction. That is the force of tension. That's going to be the rope on cart. In the left direction, there is also force of tension, but it is not as great as the force of tension going to the right. So I draw a smaller vector, and I label that force of tension. rope on cart. I'm not putting congruency marks here on the tension forces because there is a net force. So the cart is moving to the right. Now let's watch the simulation again. The cart is moving to the right. The speed is increasing. So we can indicate that by describing the motion. Cart moves right. And it is not going at a constant velocity. We could say the velocity increases. So it's moving in that direction. Here we have our schema, our force diagram, and the description of the motion.